Welcome back, everyone. Have you seen these tests before? They are tests of statistical significance, and it's a little bit hard at the beginning to know which test you use. These tests identify the p-value. You don't know what is p-value? It's a big problem, but not our business now. So to know which test to use in your experiment, you should identify the dependent variable and the independent variable and know the type of each one. Simply, the dependent variable depends on the independent variable. Like when I say renal function depends on age, it means that renal function is the dependent and age is the independent variable. And what are types of variable? They are categorical or continuous. Categorical means categories, and it includes nominal or ordinal. Nominal, just names. Jason, Jones, etc. And ordinal means names also, but ordered, like grade 1, grade 2, grade 3, grade 4, like that. And continuous is the number, like systolic blood pressure, like HDL value, LDL value, like that. And if you identify the dependent and the independent and the type of each one, you should use the test easily by memorizing this diagram. You should first identify the dependent variable, and if it's categorical, you should identify the independent variable, and if it's categorical also, you should use chi-square test. Cat, chi. I memorized it like that. And if the sample is smaller, you should use the younger brother of chi-square, which is called Fisher's exact, but it's low yield. And if the independent variable is continuous, you should use logistic regression test. In logistic regression, the dependent variable must be binary. It means that it's yes or no. And if the dependent variable is continuous and the independent variable is categorical, it's a little bit hard here. You should identify the number of groups. If it's 2 groups, you use t-test. And if it's more than 2 groups, you use ANOVA. Why I wrote ANOVA like that? Because I want you to know that ANOVA means analysis of variance. It would be written like that in the answer. Analysis of variance. And you would search for ANOVA. What is ANOVA? It's analysis of variance, and it's written in front of you. And if the independent variable is continuous, it's correlation or linear regression. If he asks about strength of relationship, you would use correlation. And if you see predict, you should use linear regression. But not any predict. Predict if the dependent variable is continuous and the independent variable is continuous also. Predict, so it's linear regression. Okay, let's practice these examples. So they compare prevalence of hypertension, yes or no, between men and women. So hypertension depends on gender. So hypertension is a dependent. Hypertension here asks about prevalence, not the absolute number of the systolic blood pressure. Hypertension, yes or no. So it's categorical. Categorical. Men and women gender. It's categorical. Cat, chi. So it's chi-square. What about mean serum creat is compared between diabetic and non-diabetic. Creat depends on diabetic state, so creat is a dependent. Serum creat is continuous, and diabetic and is categorical. Continuous, categorical, you should identify the number of groups. There are 2 groups, so we should use t-test. No problem. Hemoglobin A1C is compared between patient on diet only, metformin, or insulin. Hemoglobin A1C depends on diet and drug, so hemoglobin A1C is a dependent. Hemoglobin A1C is continuous. And diet, metformin, insulin, they are categorical and more than 2 groups, so answer is ANOVA or analysis of variance. What about relationship between BMI and systolic blood pressure is measured? Systolic blood pressure depends on BMI. Systolic blood pressure is continuous. BMI is continuous. Continuous. Correlation or linear regression? See? Relationship. So it's correlation. Predicting systolic blood pressure from BMI. Systolic blood pressure depends on BMI and age. So systolic blood pressure is continuous. BMI and age are continuous. Predict or relationship? It's predict. So it's linear regression. Determining whether cholesterol level predict myocardial function. Predict? It's a linear regression? No. You should identify the variable. Cholesterol, myocardial function. Myocardial function depends on cholesterol level. Myocardial infarction is categorical. Cholesterol level is continuous, categorical, continuous, and the dependent variable is binary. So it is logistic regression. I hope you understood this concept. Thank you.